Alexis Stesney to the office, please. Alexis Stesney to the office.
All right, so we are now moving on to Chapter 3, Section 4, which is on centripetal motion. Okay, before we really get into centripetal motion and talking about some examples of it, let's get our definitions down. So first off, the word centripetal. Centripetal is defined as moving towards or tending to move towards the center of a circle. So we're talking about curved paths, we're talking about circles, anything that has that arc to it. Okay, centripetal acceleration. If we remember what the word acceleration means, okay, change in velocity. Remember, velocity is speed and direction. So here with centripetal acceleration, we're really changing the direction that that object is traveling. We're changing it towards the curved path. Okay, because there is acceleration, we can also have centripetal force, and that's the force directed towards the center of a moving object. Okay, so 3 words, make sure that we know what those 3 words are. All right, so let's look at this example here. Okay, in our simplest form, okay, we've got centripetal force, okay, and that is pointing towards the center of the circle at all times. So this line here is our centripetal force line. So then we need to think about what's going on here. What is this representing? Well, this arrow is representing Newton's first law. Remember, this would be the inertia of that object. Remember, the inertia of the object is always a straight line. There's no change in velocity. So it has to be going the constant speed in a constant direction. So it's that straight line. You can think of it as the tangent of the circle. So let's look at this object in motion. Okay, I have it so that the centripetal force arrow always points towards the center, and that inertia arrow always points in that tangent. As we can see, as the object continues on its circular path, how those 2 objects don't change. Centripetal force always points towards the center. That inertia line always points towards the object, the direction the object was traveling. So if we imagine for a minute that this centripetal force breaks, okay, the object is going to keep moving in the direction and at the speed it was currently. So it is going to go in this direction. Okay. Back to the beginning. Again here, if this string broke here, this object is going to move in this direction. One last time, we could stop this at any point in time, and that inertia arrow is going to tell us what direction that object is traveling. Okay, let's put this into a real life situation. Let's talk about a car on a curvy road. Okay, we have a car and it is going to travel along its curvy road. Okay, as it goes through the curve, it has some centripetal force, and then it comes off going straight again. So let's take a look at the car at this point. Okay, we know that the car is currently traveling this direction. Okay, it's that straight inertial point. Centripetal force is going to point towards the center of the circle. Next point, car currently traveling in this direction. Centripetal force is going to go towards the center of the circle. We can continue to do this at any point in the object on its path. Okay, so these last 2, I want you to think about where is the centripetal force. For this first car, if I draw 4 arrows and label them A, B, C, and D, which way is the inertia of that car pointing? which way is the centripetal force pointing? Okay, and the last card, let's do the same thing. Let's have the 4 arrows. And let's label them again. A, B, C, and D. Which way is the inertia of the car pointing? Which way is the centripetal force pointing? Okay, so one more example. Okay, friction was the centripetal force in the last example. Now when we talk about centripetal force and satellites, gravity is that centripetal force. So we've got the International Space Station out in space orbiting the Earth. Okay, gravity is acting as that centripetal force pulling it into the center of the Earth. So let's look at it in motion. So again, we have a few different positions for it. Let's look at the object. So we've got the first one, centripetal force, is going to be gravity, pulling it towards the center of the Earth. And the inertia is going to be that tangent. Okay, same thing, again, towards the center of the Earth and the tangent line. And finally, the last one, let's do 4 arrows. And let's label them A, B, C, and D. Which one is the inertia? Which one is centripetal force? Okay. Again, if, for instance, gravity was to go away, we no longer have gravity, the space station would continue to fly off into space in this direction. Okay, that concludes our lesson on centripetal force today. If you have any questions, please let me know.